In this video, we'll learn how to formulate our null and alternative hypothesis. Let's have this example. If a hospital assumes that they're able to discharge their patients in less than a week on average and you'd like to prove this, then what should be the null and alternative hypothesis that we would write respectively? If we would recall, if we would have null hypothesis, most of the time we're talking about equality, or there is no change. However, if we're going to talk about alternative hypothesis, there is inequality, or there is significant change. This is no change, and this is there is change. So let's take a look at our problem. The hospital assumes that they're able to discharge their patients in less than a week on average. So this is the claim. This is the claim of the hospital that we would like to prove or not. And as you can see, we have a keyword there which is less than. So if we're going to write this, we the average, so our symbol there, let's write it here. Our symbol there would be mu. So the average of the hospital claims to be less than a week or less than 7 days. So this is now our claim in symbols. So since the claim is said to be in less than 7 days, that means this can be considered as actually our alternative hypothesis because this is something about inequality. Therefore, if we want to raise about equality, then the null hypothesis for this example would be the mean is equal to 7 days because no matter what happens, the null hypothesis is about equality. So the null hypothesis is that the mean is equal to 7 days, and the claim of the hospital would be that the mean is less than 7 days. So this would be the alternative hypothesis because we have there that it is less than a week on the average. Now that we have our null and alternative hypothesis, we have to determine its direction. The direction of the hypothesis will also guide us when we actually do our different statistical tests later on. So, as you might have seen, or as you might have remembered rather, the direction actually depends on the alternative hypothesis that we got. If the direction of the alternative hypothesis or the symbol that is used is greater than, then this is a one tail, upper tail. If the symbol is less than, then we have one tail, lower tail. And if it's not equal, then we would have a two-tail test. So in this case, we have a less than, therefore the direction of this test would be a one-tail, lower tail test. So that is one example of how we formulate our null and alternative hypothesis at the same time determine its direction. Let's have another example. If a supermarket claims that at least 95% of their products on display are not expired and you want to test this claim, then pause the video and try to formulate the null and alternative hypothesis plus determine the direction of this test based on what we did just a while ago. So pause the video and try to formulate your answer. So let's take a look at this problem. The claim of the supermarket is that at least 95%. Now, as what was shown previously, if it's percentage, this is talking about proportion. So we need to use the symbol P. And it says at least. And in the language of inequalities, if it's at least, the symbol should be greater than or equal to 95%. Or, since we're going to compute, it's better if it is greater than or equal to 0.95. 0.95. And again, as you can see, we are using inequality symbols. Therefore, the claim is for the alternative hypothesis. Now that we've analyzed that, let us now formulate our null and alternative hypothesis. The null now is always equal. Therefore, the null hypothesis is that P, or the proportion, is equal than 0.95. The alternative is the claim. P is greater than, oops, we forgot that, it should be greater than or equal to. Now, the alternative hypothesis is P is greater than 95% or 0.95. However, we might have seen here that it says at least. Why did I write greater than or equal to symbol here? But here, it's just greater than. Take note that the equal sign is already in HO. Therefore, we cannot just simply put a greater than or equal to here because the equal to is already part of HO. And based on the direction, this is greater than, therefore this is a one-tail upper tail test. So again, you have to remember that even though the claim is at least or at most, since the equal part is part of the null hypothesis, we should not put it in the alternative hypothesis. Another example. If a drug company claims that there is 10 milligrams of loratadine in their anti-allergy tablets, then now pause the video and try to formulate the null and alternative hypothesis. At the same time, determine the direction. So, let's see. The claim is that there is 10 milligrams of loratadine. Now, there is no less, more, at least, at most. Therefore, they are claiming that the mean or the average value is 10 milligrams. And since this is the claim, equality, this will be now automatically our null hypothesis because the claim is equality. So our null hypothesis would be the mean is equal to 10 milligrams. Now, since there is no direction or there is no word that an amount is bigger or smaller, that means we're just simply saying that the mean is equal to 10 or the mean is not equal to 10. Therefore, the HA or the alternative hypothesis would be the mean is not equal to 10 milligrams. And since the alternative hypothesis is not equal, therefore, this is a two-tail test. Let's have a last example. Department A claims that the mean satisfaction level of their employees is higher than the Department B. So, pause the video and try to formulate the null and alternative hypothesis at the same time its direction. So, the claim here is that the mean satisfaction level of A, Department A, is higher than Department B. So we can say in symbols that the mean of Department A is higher than the mean of Department B. This is the claim. And therefore, this claim is an alternative hypothesis already because it's claiming greater than. So therefore, our null hypothesis should be written as the mean of A is equal to the mean of B. And the alternative is this one. Now, so there we have it. We can also write it in a different way. We can say that since their means are equal, if we transpose this here, we will have the mean of A minus the mean of B equals 0. And if we do that to the alternative hypothesis, we'll have the mean of A minus the mean of B is greater than 0. This is what we were referring to as the D in the previous video. And since it is greater than, this is an upper tail test. Direction of the hypothesis is based on at least one of the following: research objectives, the related literature, past claims, observation, assumptions, opinion of experts, and of course, common sense.